In 11.1, we're going to simplify quadratic formula expressions. We solved using the quadratic formula in chapter 9, and we did simplify some of our answers. But here are some other types of expressions we might encounter so we can practice simplifying them. Okay, this does look like a solution we would get to a quadratic formula type problem. But if I look at this carefully, I can see that the square root of 28, while it's irrational, it is simplifiable. So I'm going to do 10 plus or minus. Now, if I simplify the square root of 28, what can I multiply to get 28? 2 times 14, 4 times 7. If I do 4 times 7, the square root of 4 is 2, so this turns into 2 square root 7. Okay, so now I have 10 plus or minus 2 square root 7 divided by 2, which is really saying I can either add them and then divide, or I can divide each term separately as long as I divide both of them. Okay, if I do that, if I do 10 divided by 2, that simplifies down to 5. I'm going to bring down the plus and minus. If I do 2 square root 7 divided by 2, 2 divided by 2 is 1, which leaves me just with square root of 7. So if I got an answer like this from the quadratic formula, if I simplify it, it simplifies to 5 plus or minus square root 7, which is a much nicer answer than the original expression I was given. Okay, I'm going to do something similar on the next one, and then we'll keep going from there. Okay, so this looks like a solution to a quadratic formula problem we already solved. Now, if I look at the square root of 90, let's see. Think of two factors of 90 such that one is a perfect square. So 3 times 30, no. 9 times 10, yes. If I do 9 times 10, that simplifies this down to 3 root 10. So let me go ahead and simplify that. And the entire thing is divided by 3. Now you could add these first and then divide by 3, or I can divide each one individually by 3. Because these are not like terms, I'm going to divide each one individually by 3. So if I do negative 12 divided by 3, that simplifies to negative 4. And if I do 3 square root 10 divided by 3, the 3's cancel, and I'm left with square root 10. Negative 4 plus or minus square root 10 is a much nicer answer than the original answer I found using this quadratic formula. Okay, I'm going to keep going. If you're ahead, that's fine. Just check your answers at the end. Okay, negative 5 plus or minus, let's see, the square root of 75. No, that's quarters, so let me do 25 and 3. And you can simplify these in your head if you would like. Square root of 25 is 5, so 5 square root 3 divided by 5. Okay, and again, I could add them and then divide, or I can divide each one individually. I cannot add them because they are not like terms. So negative 5 divided by 5 is negative 1. I'm going to bring over the plus minus. 5 square root 3 divided by 5, the 5's cancel, and I'm just left with square root 3. And this is a nice answer, negative 1 plus or minus square root 3. Let's do a couple more and then you can try them on your own. Okay, so 10 plus or minus the square root of 28. For 28, I could do 214. I'm going to do 4 and 7 so that it will make 2 square root 7. And I will divide them both by 2. So 10 divided by 2 is 5. 2 square root 7 divided by 2, the 2's cancel and I'm left with square root 7. Okay, let's go there one more. 4 plus minus. Okay, now the square root of 36. Well, the square root of 36 is rational. The square root of 36 is 6. Okay, so in this case, I could divide each one individually and then add them together, or I could add them first and then divide by 5. Because these are like terms, I'm going to go ahead and add them now. If I do 4 plus 6, what do I get? I get 10 divided by 5, which is 2. But I didn't consider the minus. So 4 minus 6 is negative 2 divided by 5, which is a fraction. Okay, go ahead and try the practice problems. Check your answers when you're done.